Philip, maybe you need to close that blind, please. Great. Okay, last chapter now. So for the first class here, we're looking at types of data. Have you done anything like this with a column? You've done some data handling with column, haven't you? Has he talked to you about the different types of data? Yeah. The different types of data that you can get. Yes, quantitative, that's one, yeah. Qualitative, yeah. So what's the difference? That would be a good biology definition, yes. Although not always true, but mostly true. Quantitative you usually see as numbers. Qualitative is words. But you're right. Your types of data can be split firstly into two groups. Well, no, we'll just do that tomorrow. Quantitative and qualitative. Or there's another name for them. Numerical. No, I won't do too much at once. Quantitative or qualitative. But you did those words in biology, anyways. You didn't do biology. So that's okay. So what Lena was saying is quantitative data is what we use in physics. It's data which are numbers. Yeah? Come on. So for example, when you did Ohm's law experiment, what did you measure in it? Yeah, what things did you measure? Yeah. Resistance was at the end, but the experiment, what were you measuring? Voltage and current, yeah. These are quantitative. We didn't do anything that was qualitative. What about in biology? What was quantitative in your experiments? Yeah, was it? Yeah, so what unit is that? Is that like... You measure a height of foam bubbles or something? Yeah. So volume. Yeah. And anything that was qualitative? That you did in the bio lab? Like did you measure, or what about in chemistry, maybe a colour of a pH strip or something? That would be quantitative, yeah. Anything qualitative? You're measuring some colour. Or? The pH changes colour, does it?
Yeah.
Yeah. So that's qualitative data, right? Or do you measure something on the pH strip, or you just say it changes colour?
Yeah, like we said in distillation, we use pH paper
Yes.
to know the pH in this.
So you measure the pH, yeah. Qualitative usually just has no measurement, it's just something like the paper turned red. And that's it. Yeah. Anyway, now we try to be a bit more formal here. What's wrong with you, sir? You've only been here 1 minute, what's wrong? That's right. Okay, so quantitative data is data which can be measured to a scale. Oh, look who it is. So why are you late? Huh? What? Why are you so late? You live on campus. Yep. Alright. So what I mean here is data which can be measured to a scale. So when you were measuring your enzyme activity, you were measuring it, for example, in centimeters cubed? What's it? Milliliters? What did you measure your enzyme activity in? Was it centimeters cubed? And physics students, when you measured your voltage, it was in volts, and current was in amps. So that's what I mean by a scale. Like volts, amps, centimeters cubed. So, what do you think about qualitative data? Yeah, that's what I'll do. Yeah?
By changing something. Tell me something that's
Too general of an answer. Yeah, not too far away, so we think it's more word-based. So, I think Yusra's answer is probably the closest. It's really data that can't be measured to a scale. Is data which can't be measured to a scale. So my example here, we measure current in amps, for example. And an example here, what's an example of something qualitative? Changing colour. So this would be something like maybe eye colour. Or if I want to use this classroom as an example, maybe not current in amps, what is something I could measure from everybody in this class that would be quantitative? Age, yeah, but age might be the easiest thing. So what do we measure age in? Years. Years old, yeah.
Then qualitative can be the paint.
Can be what?
Can be paint.
Paint?
Yeah.
True. Can be, yeah. Eye colour is not so interesting in this classroom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's probably 13 times brown. Or is anybody not brown? You think everybody's brown?
No, green.
Me?
Me.
I'm the only one here. So you're all no good for eye colour. You're not interesting. Everybody's brown. But at least age will be something more interesting. So with this lesson here, what I normally do is we do the questions together just to practice. So I think if you look at the first question, it says, which of the following is quantitative and which is qualitative? Do you see that there? Yeah. Now there is another word that means quantitative. What is that? It says it in the question. You see? What is it? Numerical. And then qualitative, yes, Sue, what's qualitative? Yes, you're right, very good. Categorical means qualitative. Now, for each question, you just have to say if it's quantitative or qualitative. So you can just write quant or qual beside each one, and then we'll do it together. So it really should only take you like 2 minutes to do the first question. So I'll pause this, and then I don't do so well after 20 I should. I made a mistake where in this one I should have worn short sleeves. It was a bad choice. Bad choice. Alright. So let's have a look at the first one together. So height. What type of height? Quantitative. So you got that really good. Temperature? Quantitative. Exchange rate? Exchange rate is quantitative. Yeah. Political party? Qualitative. Now this is an interesting one. Your grade. Well, grade means like A, B, C. So that's qualitative. Yeah, that's your score. So it's just a small difference. Blood type. Qualitative. Biology students know that. The ingredient. Yeah. It's qualitative. So, well, if I said like 20 grams of chocolate, that's quantitative. 20 grams. But here when I say the ingredients, I just mean like cocoa, sugar, milk. So these are qualitative then. Your MQK points? Quantitative. The time when a goal is scored? Quantitative, yeah. The names in a phone book? Qualitative. Total goals scored? Quantitative. Calories? Quantitative. The hottest month? Is qualitative, yeah. How much each of your last 4 phone bills were? Quantitative. Colour of students' eyes? Qualitative. A copy of an attempt made by a child on their standard test of the words 1 to 10. So I'll try to trick you here. What we say? Qualitative, yeah? The phone numbers in the phone book. Yeah. You got this one right at the end here. Good. I won't say what it is. So, what are we saying here for the last one? Quantitative? Yes? Why?
Because it means the numbers.
Yeah?
And not full names.
Yeah?
So
This is a perfectly good biology answer when your biology teacher says quantitative means number. Yeah? But here, it's not quantitative. In fact, this is an example of qualitative. Because the numbers are not measuring anything. They're not like if your phone number was 085 123 456. It's not like it's 085 123 456 meters or centimeters or Celsius. Is it? And for example, if I had a phone number, she had a phone number, and he had a phone number, and if we add these numbers together, does that mean anything? No. It means nothing. In fact, if you think about it, a phone number is like a name. Why do I say this? It's like a name. Yes. It's like an identity that represents each person on the phone network. So each phone number is like the name of the phone on the phone network. So in fact, phone number is actually qualitative, even though it's a number. You see that? Yeah, you see, you won't learn that in biology class. No. Okay, so now we're going to continue, and we're going to look now in the next one, in more detail, is qualitative. So qualitative comes in 2 types now. So qualitative has two types. Ordinal and nominal. So, some examples of qualitative: eye colour, grades, phone numbers, what else we say? Which month is the hottest? Blood type. Yeah, blood type. These are all qualitative data. But that qualitative data can be split again into two different types. So you can have ordinal qualitative or nominal qualitative. Ordinal qualitative is data that has a built-in order to it. So what the heck do I mean by that? Well, for example, grades are ordinal, because we all know that an A grade is bigger than a B grade, and a B grade is bigger than a C grade. So they have an order. What about medals? Gold, silver, bronze. That's ordinal as well, because gold is what? It's better than silver, and silver is better than bronze. What about blood type?
One is dinner, and one is
there's no order, yeah. You know, it's not like, oh, negative and A and AB or whatever. It's not like medals or grades. It's not like we can put them in order of the list. Yeah, you're right. You can order them by which is most common. But that would be a tad different. So that would be like frequency of blood types, or how common blood types are. Then you can put them in order. But just blood types. If I said to you, how many blood types are there? 4 blood types? Yeah. So these 4 blood types, there's no order to those 4. Yeah. And also, if you do it that way, Yusra, it will be different for each country, but you know, something like grades, like if you get an A in maths here, then every country will see that as a good result. It's not like no country will say good results in maths is bad. Right? So what do we think nominal might be? If ordinal data is data that has an order to it, nominal then, yeah, it has no built-in order. So the example we actually did earlier of eye colour is nominal. It's not like green is better than brown or bigger than brown. Brown is bigger than blue. So although more people in this room have brown eyes, we don't say brown and then green. The name, the colour, brown, blue, green, there's no order to that. Yeah? So, is data that has no built-in order to it. I'm trying to think now of your labs. Biology lab with the enzyme activity. Did you measure anything else in that experiment, or just the volume of the foam? pH? Anything else?
The amount of
temperature,
calcium,
the amount of calcium. These are all quantitative, no qualitative at all, no. Okay. Can we have some more examples of qualitative? What do you think? So we have eye colour is one. Anything else you can think of?
Countries.
Yeah, countries that people come from is one. Huh? Website names, yeah. Yeah. Anything else? Days? Yeah, days of the week. Doesn't really have an order. For example, some people start counting Sunday as the first day and some people Monday, but I mean there's no, not really has an order, although Tuesday comes after Monday and Wednesday comes after Tuesday and Monday.
Or microscopes.
Huh?
Or microscopes.
What about microscopes?
Like there is a cell or organ that we see.
Oh yeah, so like anything like, oh I actually know something. No, you did do a biology experiment where it's just qualitative data you're collecting.
Yes,
The microscope, yeah. Well, what did you, when you cut up the pig's heart or something? Or some heart?
That was not microscope, that was anatomy.
Well still, this one here, when you cut up the heart, you have to make notes of what you see. What you see, this data is qualitative. It's not a number. I mean, I'm sure you probably, well, did you even weigh the heart? No. So everything in that experiment was qualitative. And in fact, not only was it qualitative, but it was probably all nominal. You would say things like the heart had this shape, or this colour. So this will all be nominal qualitative data. Physics students, I think everything we did was quantitative. I don't think anything we measured was qualitative.
Because we can measure it, so...
Yeah, that's right, yeah. Stupid biology students, yeah. Can't measure anything. What's that? Yeah, this is where it gets a little bit unclear. So like the months of the year, you could... I suppose you might want to say it's ordinal because it has an order, but I don't really think it would be ordinal. I feel it's more nominal because I always think of ordinal meaning this. So we can say an A grade is bigger than a B grade. True? But we don't really say December is bigger than January. Although I suppose if you start counting how many days are in it, you could. So sometimes data which is nominal, you can easily make it ordinal if you have some way of measuring it as well. So for example, the months. If we care about their days, we could say February is the smallest. So this would be first in our list. But if we just list them in order throughout the year, it'd be January, February, March. So ordinal, it has to have some, I suppose I should really say, it has to have some clear built-in order. You know, it can't be unclear. It's not always clear. So this can be quite difficult. What about the names of the students in this room? Is nominal. Yeah. It's not like Stephen is bigger than or better than some other name, right? So there's no order to it. Yeah, I was waiting for somebody to say that. There's always somebody every year who says that. So the problem with alphabetical order is, you know, it is not really something that you're being measured. Like the alphabet is, do you know what I mean when I say arbitrary? Maybe not. The letters A, B, C, they're in no special order. We just put them in this order because this is how we learned them when we're little kids in elementary school. But if tomorrow people learned the alphabet backwards, I mean, it's no problem, is it? So this order is not built in. It depends on how you learned your alphabet in elementary school. But this isn't something built in natural. There is a word for that in English when something depends on its name and how you learn it in school. Does anyone know this? It's in English, it's called semantics. So another good example would be, I call this left and I call this right. But if I call this right and I call this left, and if everybody did that, then there'd be no problem if everybody uses the same name. So it's not like left is something natural and right is something natural. It's just what we call it. Like what I mean with the alphabet. So if we swap left and right, and we all swap the names together, then everything is fine. So I would say we drive on the right, even though it's still the same side. As long as we all change the name, it doesn't matter. So that's what's happening here with the alphabet as well. It's not really in order. It's just the names, how we learn them. Yeah. So in question 2, you have to say if each one is ordinal or if each one is nominal. So I'll give you again 2 minutes to do this. You can just write O or N beside it. Okay. So number 2. The names of the Irish rugby team. Nominal. The TV shows on TV tonight is nominal. The list of all TV shows for next year.
Nominal.
Yes. Actually, that's nominal. C. The names of students in class? Oh, actually, I'm going to go back to 2B. I think that should be ordinal, not nominal. Yeah. Why did I say ordinal? Yeah? The time is on that. Yeah. Okay, sorry. Back to 2D. The names of students in the class? Nominal. The people who won a medal at the Olympic 100-meter dash? Yeah, really it's actually just nominal because it's just the names of the people who won it. Yeah. The name given to each year of college. What do we think? Ordinal. Well, each year has a name, and just like medals, gold, silver, bronze, there's an order. So the first year is junior freshman, the second year, senior freshman, the third year is called junior sophomore, isn't it? And the last year is senior sophomore. So these names of each year have an order, just like gold, silver, bronze has an order. Yeah? In your high school, or in college or university, are you sure? In your home country, do the years have a name? You just call them year 1, year 2?
Yeah.
Boring. Right. G. Okay. So for the last one here, we can have our quantitative data. Continuous or discrete. So your definition is not too bad. When we say continuous data, we mean data that we can make as fine as we like. So what do I mean by fine? I don't mean good. When I use fine here, I mean scale. So for example, height is continuous because I could measure height in centimeters, or I could measure it in millimeters, or I could measure it in nanometers. I can measure height in whatever scale I want, and I can make the scale as small as I want. So your enzyme activity is continuous also, because you measured it in centimeters, yeah? centimeters cubed. True? But you also could have measured it in millimeter cubed, micrometers cubed. You can make the scale as small as you want. So this makes it continuous. So in biology and in physics, so in physics it was continuous, in your enzyme one it was continuous as well, continuous quantitative. Discrete though, this is not the case. So where discrete, the data can only be measured in units of a fixed size. So for example, something like, I don't know, did you do any biology experiment where you have to count something, like a count, 1, 2, 3? Or was everything something you measured? And words, yeah. Or what about in chemistry? No? Well, okay, I'll give you one then if you didn't do it. So if I asked each person here how many sisters and brothers they have, this data is discrete because each person can only say certain numbers, like 0, 1, 2. They can't say any number. I think pH is actually continuous because you could have pH of like 7.2 or 7.21. It's just pH, we usually can only measure it 1, 2, 3 because that's how accurate our pH strip is. But if you had a more accurate pH strip, you could measure it finer than this. So pH, I think, is actually continuous. But discrete, the data can only have certain values, certain units. We can't make the units as small as we like.
Has like the number of computers in the store.
Yeah, number of computers in the store, for example. So, an example here of continuous would be when you measure your enzyme activity. What letter did you use for that? What letter? Or you didn't give it a letter? we call it EA. And we measure this in centimeters cubed. Yeah, I'll give you a physics 1, 2 to keep you happy, okay? We measured the time in seconds on the stopwatch. Okay, now, a discrete one. So the example you gave, Lena, would be the number of computers, PCs, in a store. Or the number of people in your family. Yeah. Do you get the idea between the two? So if I said, let's see, how old you are, is this continuous or discrete? Yeah, well, you see, this is the thing. So normally it's discrete because you say 18, 19, 20. But really it could be continuous as well. So sometimes some data which is continuous, we measure it as discrete because it's convenient. You know, I am 18. We don't say 18.2. But usually, and of course some data which is some data which is continuous, we might measure it as discrete. So we can always go from continuous to discrete. And some data which is discrete almost looks like it's continuous, but it's not. And I'll give you an example with this. So if I said how much money you get paid, your salary, you see, it looks like it's continuous because you can get paid anything, but it's actually discrete because you can't get paid less than 1 cent. So you could get paid €10 per hour, 10.01 per hour, but you couldn't get paid 10.0001 per hour. You can only get paid in multiples of 0.01. This is the smallest unit. But it almost looks like it's continuous because it's 2 decimal places as well. So like someone could get paid, I don't know, 312,500.27. I mean, this looks like it's continuous, but actually it's very discrete. So sometimes what's continuous could be something that is continuous might really be discrete, and something that looks like it's discrete might actually really be continuous. What about shoe size? Yeah, what do you think? Why do you think this?
Because when you go out by shoes, you only have 10 or 10.5.
Yeah, so it's discrete then. So 10.5, 10, 9.59. Yeah. What about your trouser size? The waist on your trousers? When you buy trousers, the waist? Discrete, because it can only be certain numbers. What about your waist measurement? How big your waist is?
Continue.
Yes. You see, there's a small difference there. When you go to the shop, you can only buy the trousers in certain sizes. This makes it discrete. But you could be any size. This makes it continuous. Can you see the difference? Yeah, we'll do one more together. Let's see. Your score, the score you get in your maths exam at the end of the year, your final maths score. Discrete. It can only be certain values. Nobody can get 82.6143%. Yeah, so it's discrete, that one is. So, try number 3. I don't need you to do number 4. Try number 3 and we'll do the answers together. So, number 3. The shoe size is discrete. The income is discrete. The weight of each pair of trousers. Yeah, so this is on the trousers, so that one's discrete, yeah. Payments? Discrete. Height? Continuous. Number of steps? Discrete. NCUK points? Discrete. IQ score? Discrete. As far as I know, IQ is discrete because you can only get a score as like 100, 101, 102. I don't think they give you scores less than 1 unit. So I think it is discrete. Weight measurement? Continuous. How long a staircase is? Continuous. How much rain fell? Continuous. Because it's like height. File size on a computer. What is it? No, what do you say? No, don't be confident. Be confident. Yeah, discrete. Now, why is it discrete? Does it have the limit? Well, yeah. So, literally, why did you say discrete? Give me more. Huh? Yeah, so give me, it is discrete. How big a file is on your computer. It's discrete. So, what is the smallest unit? The smallest file you can have on your computer?
1 KB.
No, you're not something smaller than a KB because listen to what you're saying. What is a KB?
So 1
Kilobyte. So, 1 B, a byte is the smallest. In fact, there is something smaller than a byte.
Microbyte.
No. No.
Terabyte. Probably that.
Yes. Yes. How many bits in 1 byte?
1,000?
No. I think someone said it there. 8. So in fact there are 8 bits in 1 byte, and then there's 1,000 bytes in a kilobyte, and then 1,000,000 bytes in a megabyte. and then 1 billion bytes in a gigabyte, and then 1 trillion in a terabyte. But they're all bytes, and then 1 byte is 8 bits. And a bit is the smallest. Does anyone know how big a bit is, or what a bit represents?
010.
Yeah, a bit is only a 0 or a 1. So this is the absolute minimum. You can't have any information less than a bit, because a bit is a 0 or a 1. So, a 0 or a 1, that's it, yeah. That's the script, okay. The time each student wakes up at for school.
Continuous.
Why continue it?
Because some people might wake up at 8:45, people wake up at 7:15, 7:00.
This one is continuous because I could wake up at 8 and 1 second, 8 or and a half a second. You can wake up at any time.
In class, like, I thought about it in how the students and not
Oh, yeah.
in one class.
I should say for class. Although, could be in class, true. I have seen this before. In fact, I'm using in a class here to mean the students in this classroom, what time they woke up at. I don't mean in as in the classroom. I should class here, I mean the students. And the last one then, the time the student sets on their alarm clock. You can set your alarm clock for 7:20 and a quarter of a second.
No.
It depends on the time you watch it.
Yeah, and that's why here I said a Tesco alarm clock. Not a smartphone app, a Tesco alarm clock. So it's discrete because you can only set the hour and minutes, not the second and the nanosecond. Yeah? This is important, for vocabulary, because when you go on to do statistics, which you will, even if you're doing medicine or not, they will use these words without any regard for if your English is good enough to know these words. So your lecturer might say, in a biology or whatever lab or class, they might say, here is some nominal data or qualitative data or discrete data. They'll just use it. They may or may not bother to explain it. Okay? So this is useful vocabulary. And in the exam, this would be a 1-mark question. It would say something like, the data that you use in part A is what type of data for 1 mark. Yeah? Okay, let's have a look at the next one.